Let's take a look at how to identify the features of a parabola when you have the function in standard form. So let's keep in mind, first of all, you might find quadratic functions are often expressed in either standard form or vertex form. Recall standard form, f of x is equal to ax squared plus bx plus c, and compare that to vertex form. It is admittedly easier to find the vertex, the axis of symmetry, and the opening direction when you have your function expressed in vertex form. But with a little extra work, we can still identify these features when we have our function in standard form. So let's take a look at an example. Notice that we have our function written in standard form as opposed to vertex form. So our example, f of x is equal to 2x squared minus 8x plus 9. And we want to find the vertex, the axis of symmetry, and the opening direction. So when we have the function in standard form, finding the vertex is actually a two-step process. The first thing we're going to do is we're going to find the x-coordinate of the vertex using a little formula. Once we find the x-coordinate, then we can use that value to evaluate our function and figure out what the y-coordinate is. So let's start with step 1. X is equal to negative b over 2a, so our b is a negative 8, and a is 2, so let's substitute those values in, do the arithmetic. X is equal to 2, so that is the x-coordinate of our vertex. And now let's find the y-coordinate of our vertex by substituting in 2 as our input into our function. And now crunching the numbers, doing the math, we get that f of 2 is equal to 1. Now we have the x and the y coordinates of the vertex, 2, 1, which means that our axis of symmetry, x is equal to 2. And now we have to figure out our opening direction and recall that the opening direction is based on the coefficient a, and if you compare the two forms, standard form and vertex form, a is the same number in both of them. So we can still easily tell which way our parabola is going to open. Our coefficient a is 2, which is a positive 2, so upwards is how our parabola is going to open. All right, let's try another example, and if you want, pause. If you feel confident, go ahead and try to do this, and then we'll work it through. Let's start our two-step process by first of all finding the x-coordinate. Our b coefficient is 6. Our a coefficient is a negative 3. We plug that into our formula, and we calculate that x is equal to 1. Now we're going to use that 1 and evaluate our function. Plug the 1 in for x, crunch the numbers, we get f of 1 is equal to 0. That gives us now both the x and the y coordinate. The x we had found previously is 1. The y coordinate we just found is 0. The axis of symmetry is x is equal to 1. And if we look at our a coefficient, it's negative, so our parabola is going to open downwards. So what did we just do? Well, we remembered that we can get quadratic functions in standard form or vertex form or actually anywhere in between. And this is what standard form and vertex form look like. And then finally we saw that, yeah, it is actually easier to work with vertex form if what you're looking for is the vertex, but it's really not that much harder to find the vertex when you've got your function in standard form.